Hi folks, Jack Summers here. I'm going to talk to you today about, well, this is the second video in a series of two about measuring chemical kinetics using some homemade instruments and doing the analysis. Today I'm going to show you some spectral analysis using this spectral analysis for kinetics program that we wrote in processing. Okay, so we hit the run button and that opens up our user interface. Okay, in the last video I showed you data collection for a chemical reaction between sodium hydroxide and crystal violet, and today we're going to now analyze the data. So we need to load the file. Last time we did that we saved it as JS data 9 or something like that. Okay, so we call it up and that's what the data looks like. Alright, so now we need to select a background, and right here, that 25-second background, these are the times that these spectra were acquired in. That's the 25-second time point there. So we've selected that as our background. If we hit process, it's going to do the background subtraction. It's going to smooth the data. 17 points are going to be average for each data point that's shown. It's going to trim it, and it's going to trim the data between 400 and 700 nanometers, and we can change that trim value. Let's say we want to go from about 450, which is like right there, to a little less than 700. Let's say about there. Okay, so now we've selected our region, and I think we have to hit that. So now it's going to use the box, the dimensions of the box as the trim region. Okay, so it's going to do the background subtraction based on the 25-second data point. It's going to smooth the data and trim the data off. Okay, so now we're ready to process. We hit the process button, and that's what the absorbance data looks like, right? We can go back to the, see it says now that it's absorbance data that's showing. We can take a look at the raw data once again, or back to the absorbance data. Alright, so that's what the absorbance data looks like. We can call up a cursor. Okay, so here is that's how you call up a cursor. The cursor is at 561 nanometers, and we can drag that over and see where our peak is. And let's say we want to look at the change in absorbance at the 590 nanometer position. So we're going to come over here, and these are our analytical wavelengths. So we can choose the analytical wavelengths we want to use. 590, 570, and we have boxes for 5 of them, but so far it's only got, right now it's only it only has data manipulation for 4 of them. Alright, so we put our analytical wavelengths in here, and now we're going to do the kinetic analysis, which is done by hitting that button there. Alright, so we now have the kinetic data that is displayed here. This is for the 590 nanometer absorbance as a function of time. The 570, 550, and 520 are in the blue, green, and purple data points respectively. The lines represent the best observed rate constant for a pseudo first order process. Okay, so if you want to do other kinds of processes, that'll involve some code writing and that sort of thing. So that's where we're at. We can get the best observed rate constant for the data that we have, and I think it's pretty nice. But we're still working on it, and we will look at other rate laws at some point. Alright, so that's what we have, and I thank you for watching.